Hey, welcome back everybody to my YouTube channel. Today I'm going to go over sorting, and what I'm going to go over is a straight selection sort. I'm hoping that we can get through this in one or two parts. I will see how long this video goes. I don't want to take 20 minutes. I just want to do it in 10-minute parts so that we dissect it accordingly. Now there's different sorts that sorting algorithms that are out there. But in this specific class, we're going to go into straight selection sort, and then you can probably apply this to the other sorts, such as the bubble sort. If I have time, I can post another video on the bubble sort, but you can use the same approach for the bubble sort, because once you start understanding how things move around in an array, it will be very, very similar to the other sorting algorithms. And then obviously when you get to data structures, there's going to be other approaches. But these are sorts that are quick and easy, and they're good for a fundamental programming class, which is a good start for you to do. So let's get to it. Okay, so obviously when you're sorting, you have to have an array. And the way that I like to teach this is you always start out with a simple 5-element array. And you'll have 0, 1, 2, 3, and 4. So your size is going to be 5. Okay, so I do want to get some things out of the way so that we understand. One other thing that I forgot to mention is that if you are gonna view this video, make sure that you view my previous videos on arrays and just how to traverse through an array and so on, because you can't learn sorting without understanding arrays completely. Okay, so a couple things to get out of the way. The first thing is, what is the size of the array? So my size of the array is 5, and the max index is going to be size minus 1, right? Any array, my max index is going to be size minus 1, because we start at the 0th element. Now with the straight selection sort, we're going to use integers, okay, just to make things easier. Okay, so we're going to assume that we have an array with the following values. So the way that I like to do this is I actually like to write out the traversals first on paper, and then I will talk about the code, and we'll write the code together on Replit. Now, what we're trying to do here is we're trying to sort this array going from min to max. So it'd be helpful, I think, if we draw out the resulting array. Okay, so we want to get from this to an array that looks like the following. You want to have 2, then you want to have 7, then 17, 29, and 53, right? And also, one thing that I did want to mention as well is that I hope that you looked at my video on swapping, right? Swapping is very important when you're doing a sort. So again, this is what we're gonna be using the straight selection sort. Very inefficient because it's very slow. And the time complexity of this is O of n squared. Okay, and you'll see why, because usually it has an inner loop, and we constantly have to traverse through that inner loop. So it's the time that it takes to complete is going to be exponential in the worst case scenario. Okay, now we have these values here, and the straight selection sort says that we build a wall. Okay, so we build a wall, and we always build a wall at the initial index, right, of the unsorted array. So the initial index here is 0, right? So what we want to do is we want to traverse the array and then find the smallest value. When we find the smallest value, we want to swap to the lowest index of my unsorted array. Now you'll see that in this particular case, which is the first case, the first traversal, the lowest index is obviously 0 because the whole array is unsorted, right? So on the first pass, we're going to find that this element is the smallest, right? We still have to, even though we found this to be the smallest, you still have to traverse and look to see if there's any further elements that are smaller than 2. And you're going to find that as you go through till the end, you're not going to find anything smaller than 2. So what happens is you keep that small value and the small index, and then you swap it with the lowest index of the unsorted array. So let's write these things down, okay? So the first thing that we have to do is establish the lowest index of unsorted array. In this case, we found that the lowest index of our unsorted array is 0, right? Once we establish 1, then we can find the lowest value, right? So in this case, what was our lowest value? We found that it was the value 2 at index 2. And then the third step is we swap whatever is in 2 with whatever is in 1, right? And we swap back and forth so that my resulting array after the first pass is going to look like this. You're going to have 2, 53, 17, 7, and 29. 3, 4. Okay. And, sorry. Which ones did we swap? Well, we swapped this thing went over here, and this thing went over here, right? Now, the unsorted part now gets moved up because we know since we traversed the whole array, we've already found the lowest value, right? And we know that the 0th element has the lowest value of the whole array. Remember, we traversed the whole array, which means that now we move up the wall and we now have a wall up here. Now on the second pass, we can determine, I'm going to erase this so that we can have more space here. We determine that the lowest index of the unsorted array is no longer 0, but it's going to be 1. Okay, because we're over here now. We remember we moved up the wall. And then now we need to traverse again, and we need to find the lowest value. And when we traverse and find the lowest value, we find that the lowest value is over here, right? So what is our lowest value? Our lowest value is 7, and that's located on the 3rd index. So now on this traversal, we're now going to swap the whatever is in index 3 with not 1, but now whatever is in index I'm sorry, we're gonna swap what we just did in terms of the numbers, okay, not the element. So this gets swapped and this gets swapped, right? I'm just indicating that we swap numbers 2 and 1, and it's a little confusing, but I'll keep it that way. So as you look in the array, we have to now take this value and put it over here, and take this value and put it over here, so that our resulting array is now 2, 7, then 17, 53, and then 29. Okay, so on the second traversal, after everything's said and done, the resulting array is going to look like this. And now we moved up the sorted versus the unsorted, right? Now the wall goes over here. Anything behind the wall, we can say that it's sorted, and anything after the wall, we can say that it's unsorted. And we go through these steps again over here. Okay, we can establish now the lowest. What's the lowest index? The lowest index of the unsorted array is now 2. Okay, and then what's the lowest value? Well, that we have to loop through and find the lowest value. In this case, we don't really have to go far, but we still have to look through, right? So a lot of students make the mistake that they see the array, at least the unsorted part, right? They see this part and they say, oh, why do we have to keep going? Why? We know that 17 is the lowest. Yes, because you see it from a kind of a two-dimensional view, right? So you're seeing it from up top, kind of like if you were on an airplane. But the computer doesn't see it that way. The computer can only see what's in front of it. So when the computer starts traversing through the unsorted array, it really only sees 17. It can't see forward, right? And it can't see backwards unless you tell it to. So in this case, when we're at the second element, what is our lowest value? The lowest value is 17 because we don't know any better, right? We don't know if the third index is lower than 17. At least the computer doesn't know. We do, but the computer doesn't. So that's why you have to keep traversing. Now, as we get to the next element, right, this is no longer 17, it becomes 53, right? And we know from our, so this is 53, this is the third element. We know that from our days of, or videos of finding the max and the min, we know that we're going to compare as we go through the array. Okay, so if we compare 53 to 17, we know that it's still not lower, right? And logic tells us that our loop will determine that this is the lowest value. And yes, you can just keep it swapping to itself. So it's going to swap it to itself, right? Because our lowest index is 2, and our lowest value is going to be 17 at index 2. And that's okay, right? That's okay. That's okay. We can still have that. Okay. Now, if you continue this on, I'll leave that up to you as a homework assignment where you want to traverse to the next element and push the wall up one more, and then push it up one more, and then you're eventually going to push up the wall to where you're going to stop, which is going to be size, right? So if you're thinking about a loop, you're going to go up to size. Okay, on the next video, I'm going to talk about the Replit code, and we can get more into the nitty-gritty of the actual C++. I'll see you on the next video.